Hello everyone, my name is Muhammad Farhat. I have almost 20 years of experience in oil and gas industry. I am a geologist. Uh, First of all, hope everything is going fine with all of you. As usual, safety first. Before we start our quick journey today, a safety moment. It's just a quick and a gentle reminder. Please keep social distance, trying to avoid corona as much as you can, follow the health instructions, apply all of the protection rules if you please. Today, under the title of the Field Development Plan or the FDP's projects or studies, I would like to talk from geoscience point of view with all of you, and some hints about the Earth modeling as well. The agenda. Quickly, in brief, covered introduction, technologies, objective, workflow, and way forward. Theory. I would like to say Earth modeling, for example, it's just a part of the field development plans, projects, or study. It applies different conceptual models of the individual's domain. So, for example, if we got that geophysics domain or the geology domain, petrophysics domain, every discipline has its own model individually. So, Earth modeling as a terminology indeed is an old terminology because it exists and found in every domain. Domains must building the required conceptual model, then gather or connect all of this information together in order to come up with one robust, let's say, scenario. So, technology. I would like to say technology here is highlights the importance of the machine learning. So it's nowadays where everyone in the oil and gas industry talks about the machine learning or the data science. So in brief, maybe for 40 years ago, maybe more, data science companies founded and designed plenty of applications for oil and gas industry. We got plenty of examples. Many applications and softwares exist commercially, and the oil and gas industry, I believe, used all of these applications. So the construction of the Earth modeling, for example, based on the integration of the GeoScientists, used at least more than 10 applications or softwares for correlation, for plenty of purposes. The objective. Every geoscientist, during consuming or running or executing the FDP's studies or projects, got many objectives, but the main three objectives: exploring, developing, maybe prediction or planning process, connecting and linking all of the geoscientists and engineering data together in one body to understand well and solve the puzzle better, to understand the big picture of the field. also to define and understand or determine the capabilities, limitation, and uncertainties for optimum field development purposes. So that figure is displaying the efforts of Mohs. He has created a scale for the hardness of the minerals. So Mohs has provided an effective analog used as a reference for valid benchmark scheme or schema. So I would like to say that the objectives, the main objective of the geoscientist during or while running Earth modeling or run any step or the let's say the Gantt chart of the FDPs, they are trying to, because it's endless of the development process. Once it's started, you have to back again, so it's back and forth process, so it's a loop. So that requires Mohs concept to be applied. Create an analog, create your reference. So workflow. That funny diagram I draw. On the right hand side, there's that triangle, a normal triangle, I would say. On the top of that triangle, you got the science or the theory or the engineering science itself, the science itself, and the arms is the manufacturing and the mechanics. So any machine or device, tools has been invented, like by the scholars, scientists, legends through the history, like Thomas Edison, Bell Graham, Abbas ibn Firnas, Wright brothers, even Alfred Nobels. In our oil and gas industry, you can mention about Darcy. In the sedimentology, I would like to mention Professor Roger Slatt and Professor Puma as well, maybe Tucker, P.T. Joe, and many names, many scientists and geoscientists and engineers. They actually helped the humans to develop and invented lots of. So that is the normal triangle on the right hand side. But what about that the opposite way of the triangle, an upside down triangle? And I give that funny title, which is a constitution that is not scientifically written yet. So that I would like just to give a quick example regarding that opposite triangle. Everyone remember the seismic acquisition in the oil and gas industry, and back to maybe 50 years ago, the industry of the oil and gas, all of the oil and gas, oil companies depend on and based on only the techniques of the gravity, magnetic, and electrical tools or techniques to draw and to map the subsurface. So in order to create the maps, subsurface maps, contoured one, and later on the industry itself come up with the seismic acquisitions, and it matched the old techniques, but it's enhanced or advanced, latest, greatest techniques. So I would say that tools or that application or that softwares which already exist commercially for oil and gas activities. It doesn't learn or teach you geology or geophysics or petrophysics or any domain or any discipline. It doesn't show you the concept of the science itself, but it provides you some way of the apply science, the application of the science itself. So it displays and shows techniques of any, I would say, commercial tools in the industry. So schools, legends, principals, scientists, I believe they are working very hard, and they already started and still working very hard to write down an academic text or book, reference I mean, for education purposes, not belonging or engaged to catalogs or the manuals or the software of application. Once we got that reference in the academic or the scientific library, I believe that triangle will convert upside down again to back to the normal triangle, not the as on the left hand side I draw this way. So I think that diagram might be maybe a comprehensive possible workflow. Maybe you agree or disagree with me. Included your, I would say, the uncertainties which exist in the project, analogs, thoughts, the principles or the fundamentals which is already understood. Around all of these, we got all of the disciplines together, integrated, exist for even deterministic or stochastic, conceptually or estimated scenarios or thoughts or models. Maybe later on I will give some lights on quickly some 4 or 5 items like rock types approach and reservoir characterizations, then maybe conceptual models or the scenarios, and hydraulic zonations as well. I hope you find this useful and maybe interesting, hopefully, and I wish you all the best. Please stay well and keep safe, and speak with you later. Take care and bye.